Arterial blood gases can look intimidating, but you can interpret any result in 5 simple steps. Let's break it down. Step 1, pH. First, check the pH. Normal is 7.35 to 7.45. Below that means we have acidemia. Above that, we have alkalemia. Step 2. In step 2, we have 2 players. Partial pressure of carbon dioxide, which has a normal range of 35 to 45, and bicarbonate, which is normal between 22 to 26. Now let's match the story. If we have acidemia with high CO2, that means we have respiratory acidosis. If we have acidemia with low bicarbonate, that means we have metabolic acidosis. Alkalemia plus low CO2, that means respiratory alkalosis. Alkalemia with high bicarbonate means metabolic alkalosis. In other words, if the problem comes from CO2, it's respiratory. If it comes from bicarbonate, it's metabolic. This is the core of arterial blood gas interpretation, these 4 rules. Now let's move on to step 3, or compensation. The body doesn't just give up, it tries to correct. If it's metabolic acidosis, the lungs try to blow off CO2. If it's respiratory acidosis, the kidneys try to retain bicarbonate. Now, there is a third option. If the numbers don't fit the expected pattern, for instance, we have metabolic acidosis, but the lungs aren't blowing CO2 off. We have actually also high CO2. In that case, we have a mixed disorder. So in step 4, we look at the oxygenation. Normal partial pressure of oxygen is 80 to 100 millimeters mercury. Anything less than 60 means respiratory failure. There are 2 types of respiratory failure. There is type 1, in which we have low partial pressure of oxygen with normal or low CO2. Type 2, we have low oxygen, but we also have high CO2. Now, the target saturation of oxygen has to be above 94% unless the patient is a chronic CO2 retainer. In step 5, or our last step, we calculate the anion gap. We only calculate it if we have metabolic acidosis. Sodium minus chloride plus bicarbonate. Normal is 8 to 12. If it's elevated, it means there is an additional metabolic process at play, like lactic acidosis or ketoacidosis. Thank you for watching. Check out the next video in which we can interpret a couple of ABGs together.